So we're continuing to talk about products, factors, and factoring quadratics. Yesterday, we introduced vocabulary that was very fundamental, and we started to talk about factoring the GCF, the FOIL method, which is basically what the factoring is based off of, right? It's the opposite of the FOIL method. And then we did some factoring with some quadratics here. And we're going to continue with this example, factoring completely. So yesterday, we first factored the GCF, then we factored quadratics. But when you are asked to factor completely, that means that you need to do both. Factor the GCF first, and then whatever remains, make sure it is factored to its simplest form. So we have the example 2x squared plus 16x plus 30. Now when we look at this, we see that the coefficients 2, 16, and 30 are all divisible by 2. So we can factor out a GCF of 2 and be left with x squared plus 8x plus 15. But the quadratic that remains, x squared plus 8x plus 15, can be factored further. So we want to factor it into two binomials. So I start with my signs. The second sign is positive. So whatever the first sign is, it goes in both sets of parentheses. X squared factors into x times x. And 15, we know factors of 15 are 15 and 1, or 5 and 3. Well, we need a middle term of positive 8x. So of course, we're going to use the 5 and the 3. And since both sides are positive, it doesn't matter where you put the 5 and where you put the 3. Now we have factored the original expression completely. The next thing we need to talk about is recognizing and factoring a difference of two squares. Right? Recognizing a difference of two squares. The word difference is the answer you get when you are subtracting. We'll look at our examples. Minus, we're subtracting. Minus, we're subtracting. And minus, we're subtracting. So each of these three examples is a difference. The two squares part is short for two perfect squares. A perfect square, like 4, is a perfect square because it's 2 times 2. X squared is a perfect square because it's x times x. 9 is a perfect square because it's 3 times 3. 9a squared is a perfect square because it's 3a times 3a. 16 is a perfect square. You know that it's 4 times 4. And we can keep going here. 25b squared. 5b times 5b. And finally, 4a squared is 2a times 2a. So you recognize that each one of these is a difference of two perfect squares. And these are extremely easy to factor. Set up your parentheses. X squared is x and x. 9 is 3 and 3. They both have to be positive. Excuse me, not both positive. One has to be positive and one has to be negative. So that the outside inside of the FOIL cancels out that middle term of the quadratic. That's why each of these examples only has 2 terms. 9a squared minus 16. Set up your parentheses. 9a squared is 3a times 3a. 16 is 4 times 4. Positive, negative. And finally, 25b squared minus 4a squared. 25b squared is 5b times 5b. 4a squared is 2a and 2a. And we have a plus and a minus.